Well, hello and welcome to the last section on electrochemistry. I'm going to talk about a few electrochemical topics. First one here, electrolysis of water. You can break apart water using electricity, uh, using connecting up as such the positive end of the battery to water. You just connect the battery up to water, and the anode will proceed as such, anode and cathode, and along the anode you will form oxygen gas, and along the cathode you will form hydrogen gas. And this has been slotted as a way to make hydrogen gas. Typically, though, we don't do this; it's too expensive. Where this is used is on nuclear subs. This is how the sailors get oxygen, using lots of ample water supply in the ocean, and the oxygen is then used, and they dump the hydrogen in the ocean, and it typically just dissolves at that pressure. That's not how we typically get hydrogen in industry. Hydrogen in industry is typically made by steam reformation of methane. That's one way. The other way is by the reformation of hydrocarbons. So you cyclize hydrocarbons, hydrogen pops off. That's in oil refineries. So we usually make hydrogen. Hydrogen's a byproduct from the oil refinery in that way. But if you want to directly make hydrogen, this is the way you do it, is with methane and in water in the process called steam reformation. Typically don't use water as far as hydrolysis, though. We can also use for electricity for plating of metals. If you want to buy cheap rings and cheap jewelry, so if you want to give, I remember I gave my high school girlfriend a gold set of earrings. We were no longer dating, but that's neither here nor there, of course. But it was electroplated. They were like $20. Right? I mean, it was obviously electroplated. And the way you electroplate is that you have the noble metal as the anode, and you apply the current through it, and then you have a metal ion solution, and you put something in there, and then as long as you electrically connect it to your source, you will plate it with the silver, gold, whatever noble metal you want on there. And typically, when they do this, they have some really old technology. If you wonder, well, how do you prevent things from just plating the metals? You can use plastic, or a lot of them use wood. So you have a wood support sticking into that, and then of course an insulated wire. You have the not nylon around the wire, because if you have electric connected, you're gonna just plate the wire with the metal. So they put. But like I said, the structure is that is wood. Not so much in Hawaii, but if you go in the mainland, you'll see lots of trucks have really shiny, pretty chrome on them. The way they do that is they put a pretty thick layer of nickel down, and they put a thin layer of chrome. That we found out the thick layer of nickel prevents sheet corrosion, because if you can corrode along the edge, and then you can get the chrome falling off. So we found out by trial and error that electroplating with nickel first and then chrome gets that pretty shine if you want the real shiny mirrors. So let's do a problem like this, and there's a problem like this on the final, so pay attention. So gold can be plated out of a solution by this half reaction, and what mass in gold in grams is plated by a 25-minute flow of 5.5 amps of current. So the way you do this is dimensional analysis. So 25 minutes, so times 60 seconds per minute, and we have 5.5 amps, that's 5.5 coulombs per second of, it's an ugly line there, 5.5 coulombs per second. And how many electrons is that? This is a mole of electrons per 96,485 coulombs. And now we have to look to this equation. There is a 3 to 1, so there is a mole of gold per 3 moles of electrons. And the last step is a molecular weight. I think it's 197 grams gold per mole. I have to look at the periodic table real fast. Let me take a look. I think the atomic mass is 197. Gold is 197. Ha! Chemistry superstar status intact. All right, and then you just calculate that out on your handy-dandy calculator. Okay, after throwing it in your calculator, you get 5.6 grams of gold. So that's how you can electroplate some cheap earrings to give as presents, I suppose, for those with limited amounts of budget. Okay, so also, if you wanted to know how bleach is made, so there's two ways you can make bleach. So the old way of making bleach is you take salt, and like sodium chloride salt, and you melt it, and you connect it to a battery, and then the anode would be the chlorine, and the cathode would be the sodium. So then you would take the chlorine gas and bubble it through water, and then throw the sodium into it. Or you could take the sodium, throw it in water, and bubble the chlorine gas through it, then make sodium hypochlorite. This way of doing it, you can generate bleach and or chlorine gas this way, using just an aqueous solution of salt. This is in part how the alkaline water, if you buy those machines where they make alkaline water, you're just really making bleach. So if you really want alkaline water, just take water and add a few drops of bleach to it. And just be careful not to add too many, because it might taste kind of bad. It tastes like drinking pool water. But that's basically all. I mean, when you buy alkaline water, that's all you're buying, really, is just this stuff. It's also how we purify water. We usually take the chlorine gas and we bubble it through, at least here in the United States, we take chlorine gas, bubble it through water, and that's used as a disinfectant. So other places in Europe, you can use ozone as a disinfectant. You can also use ultraviolet light. That's also commonly used to kill bacteria. The thing about chlorine, though, is it sits in the water, and it keeps from after it's sterilized, it gives it a longer shelf life of sorts. So last topic is corrosion. And corrosion is a problem that affects things in the billions of dollars. So anode corrodes. So if you have iron, and the iron metal itself is the anode, if you've noticed, where does corrosion happens? It happens where things get wet. So when you have that water droplet, you have a place where the ions can transport. That's your salt bridge. And then your rust is your iron oxide. That's your cathode. Your cathode grows. So your anode corrodes and your cathode grows. And it's the oxygen that does that. Oxygen in the air dissolved in water. How to prevent corrosion, and specifically we typically talk about iron corrosion, but other things can corrode. For iron corrosion, what can you do? You can keep it dry. Not always an option. Also, keeping it dry prevents the salt bridge from forming. Another thing you can do is create what's called a sacrificial anode. So a metal that's more reactive than iron, typically zinc. So like there's a huge pipeline that runs natural gas from Alaska to the Pacific states, and it runs through Canada. Really long pipeline, and it's made of iron. And what happens is that every couple of sections they have a piece of zinc, a large piece of zinc, that they attach to it, and they dig it and bury it in the ground. But every couple of years they have to go and they have to dig it up, and they have to replace the slug of zinc. And the slug of zinc typically is corroded down to almost nothing. They do this because then the zinc gets corroded and it protects the iron. That's called a sacrificial anode. And that's the whole idea behind galvanized steel. Galvanized just means coated in zinc. And then the last thing is passivity. You can prevent corrosion this way. For iron, maybe you've seen some kind of dirty looking brown building sometimes. That was kind of in style in the 70s. If you take iron and you spray it with nitric acid, it makes it react, forms a thick layer of oxide, and a thick layer of oxide prevents the corrosion. So unfortunately for iron, iron oxide it's pretty flaky, so it's easy to scrape off. So other metals, so titanium and aluminum. Titanium and aluminum, they're both very active metals. Okay, so they're more active than iron. The difference between iron and titanium and aluminum is that they form oxide layers, and the oxide layer is really thick. Well, it's strong. So titanium oxide is really strong. Same thing with aluminum oxide. Aluminum oxide is also known as sapphire. So it's the second hardest naturally formed mineral. So aluminum is already naturally pacified. So, at least here on Earth it is. And with the exception is that chlorine can penetrate through the passivated layer. So that's why you don't see aluminum pipes or aluminum fittings on water, because we chlorinate the water. You also don't see aluminum boats in the ocean because they'll corrode in the ocean. So that's why we're like, why do you have steel vessels in the ocean? It's because the aluminum ones would corrode. Titanium's okay. Titanium is expensive in the ocean, but what penetrates through the passivated layer, titanium, is methanol. So that's one thing with titanium. You got to be careful with that. So, but it's interesting. So, but this is how you prevent corrosion. And like I said, it's a problem that's in the billions of dollars per year. Okay, so we're done with electrochemistry, and the last topic we'll talk about is nuclear chemistry, coming up next.